I'm going to hide off camera today to talk about 5.10 Deluxe, not to be confused with 5.10 Supreme. Some quick questions to ponder. Do all systems of linear equations have a solution? This is a fun little thing to ponder. Well, if we had a line like this, and we were asked if they have a solution, do all systems have a solution? Well, let's see. This would definitely have a solution because they intersect here. These lines, if they were parallel, what do you think? Would these have a solution? No, they wouldn't. There would be no solution. So we are able to say a few things now. We're able to say that parallel lines have no solution. So if we wanted to answer this, do all systems of linear equations have a solution? We'd say schnoll. Take this to the next one. Can a system of linear equations have more than one solution? Well, let's experiment again. If we have one line in blue, if we have another line in orange that matches the same path, do these have, well, let's see, how many solutions do they have? They have one here because they meet here, but here and 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 here, and even ones I missed. But we would say that this has infinitely many solutions. Solutions if the equations in the system map out to be the same line. So infinitely many if it's the same line graphed out onto itself. So in this case, can a system of linear equations have more than one solution? Yes, we see it here. Makes sense? Capiche? What are some ways that we could see if there's a solution to a system? Well, we just did some of these. We could graph. We could use elimination, try and cancel a variable. We could use substitution, which we saw previously. Those are three ways. Did I spell substitution wrong? I did. Substitution. All right, sound good? So you're making these shopping scenarios to talk about these systems. I'm only going to make one because it's pretty much the same song and dance for the others. So let's say that I buy 3 packs of peanut M&Ms, personal fave. And let's say that I also buy 4 bananas. $23. Let's say that I buy this at Aldi. And then let's say that I do the same thing, but now I'm buying 5 packs of peanut M&Ms, 3 bananas, but now for a total of $31. And let's say that I get this deal at Giant. What could be asked of this? You could be asked, what's the price of M&Ms and a banana if Aldi and Giant have the same prices? Kind of fun to think about. Hitting all the food groups there with peanut M&Ms and bananas. So this creates a system similar to this where, again, we could use substitution, we could use elimination, we could graph, but I'm going to use elimination here because I got some numbers and I'm pretty confident I can work around them. So let's imagine that I wanted to eliminate X. That means that I would either have to end up with this as the opposite of this X term or this as the opposite of this X term. So this can be kind of tough, but I know that 3 and 5 are what I'm going to kind of work with. Well, I know that 15 shares factors of 3 and 5. So if I was going to eliminate x, I would be trying to get a 15x and a negative 15x to cancel. So to make that happen, I'm going to multiply this first equation by negative 5. I'm going to multiply this second equation by 3. I'm going to distribute accordingly. So this could be rewritten now as negative 15x minus 20y equals negative 115. This is now 15x plus 9y equals 93. We can now eliminate x. That's gone. This is now negative 20y plus 9. So negative 11y. Does that sound good? What do you think the rest is going to be? Let me know. You should have been saying that y eventually is going to get you to here, but it's a negative 22, eventually saying that y equals 2. So what's this now saying? This is saying that the price of the bananas, so a banana, B-A-N-A-N-A-S, banana's going to be $2. What do you think the M&M pack's going to be? Well, you know y, if we were going to get at, solve for x. We got 5x, we're adding 3, but now instead of y, we can write 2, and that should all equal 31. So we can rewrite this to 5x plus 6 equals 31. So much fun. 5x is going to be 25. X is going to be 5. So we can say that the M&Ms are going to be equal to $5. We could even check our work if we wanted to. Plugging it back in, our orders should be sufficient. I'll see you in the next video or next problem. See you there. Pause the video if you need this. So a new system, new us. Take a moment. How do you think you could solve this using elimination? Well, hopefully you see a pattern here where 2 is a factor of 4, 3 is a factor of 6, 14 is a factor of 28. So let me just entertain this. This isn't necessarily going to eliminate, but let me just think. If I were to distribute 2 to all this, this will leave us with 4x plus 6y equals 28, right? And doesn't this match exactly our second equation? It does. So this is similar to what I said at the beginning. So we have the same equation, both lines of our system. We can say that there are infinitely many solutions, which means that if we plugged in x as some number, the y coordinate's going to have to be that opposing number, and that would work for both equations. It's kind of cool to think about. Graphed out as the same line. See you on the next problem. Looks like DS. Try it. Give it a shot. I will push you in the direction to try and multiply this by -3. See what happens. So if you distributed -3 correctly, you would get -9x minus 6y equals -60. Of course, this is as if we took -3 and multiplied it with equation 1. You know what I mean? So let's imagine that we try to combine straight down. So wouldn't these cancel? And wouldn't these cancel? Leaving us just 0. But then way out here, we're left with what? -25? Is this a true statement? No, it's not. So since we were able to eliminate all of our variables and get left with a false statement, we're able to say that there's actually no solution. Or if you were graphing this, we would have parallel lines. And again, this is all because our variables eliminated completely, statement left was false. So we're able to say that there's no solution. Sound good? Capiche? See you on the next problem. Pause it if you need this. This is some more practice using elimination. Well, what do you think we could do? I think and again, you have a few options. I'll list out one of them. So one of your options here, you're going to eliminate the x term. You can multiply -5 times equation 1. You could multiply 4 times equation 2, and then combine. That would cancel x. You could also do what? -3 times equation 1, 2 times equation 2, and that would cancel y. Those are two options. If you want to try one of these out, go for it, but I'll show some work on this in a second. If you knock this out going with option 1, the work would look like this. Lo and behold, our x terms cancel. We're left with 2y equals -4, y equals -2. People hit me up on Twitter and always ask how you can get a hold of the other variable. So let me ask, just pick one. Just pick an equation you want to deal with. Personally, I would go with the numbers that are easier to work with, which I'm going to say is the first equation. So I'm going to use equation 1 in an effort to solve for x. So I know y is -2. So that means 4x plus 2 times -2 equals 8. This means that 4x minus 4 equals 8. If we take this further, we're going to get that x's trace. And I know that I haven't asked you to check your work too much on this, but I'm going to do that right here. I've got the time. You've got the Wi-Fi. It can be done. You're not afraid, are you? So this is 12 minus 4 equals 8. Lo and behold, the equation 1 checks out at 8 equals 8. If you check equation 2, this should say another true statement. 5 times 3 plus 3 times negative dose should equal 9. Let's entertain it though. 15 minus 6 equals 9, which is true. 9 equals 9. That's true. Lo and behold, we checked our work. We only have one solution here, and it is the ordered pair of 3, -2. Capiche? Sound good? The exit ticket here. Now there's a challenge. You can try it if you want. The exit ticket has you sketching out the types of solutions that we came across. So we saw the following. We saw that if we have one solution, it means that the lines intersect at one point. So this is one solution. If we have two lines and they are parallel, imagine that those are parallel. So if we have parallel lines, no solution, meaning that it looks something like y equals 2x plus 3, and also y equals, I don't know, 2x minus 1. If you're big on slope-intercept form, you could say that they have the same slope with a different y-intercept. You could also say same m, different b. You could also say same mother, different brother. Capiche? Sound good? And then you have the infamous infinitely many solutions, which is this. It's like, geez, don't they know I'm recording a video here? So the same equation, lo and behold, it's the same equation, infinitely many solutions. There you go. Hope the video was helpful. If you have any questions, holler, let me know. Thanks for watching.